What's going on, MCHE 3920? Hope everyone is doing fantastic. Today, our goal is to explain to you in depth how lean manufacturing plays a key role in everyone's favorite tractor company, John Deere. There's a demand for food, and What's going on, MCHE 3920? Hope everyone is doing fantastic. Today, our goal is to explain to you in depth how lean manufacturing plays a key role in everyone's favorite tractor company, John Deere. Many large-scale manufacturing companies are using lean manufacturing principles to eliminate waste, optimize processes, cut costs, boost innovation, and reduce time to market in a fast-paced, volatile, ever-changing global marketplace. Lean manufacturing is essential to become a leader in any given market. Ford and Toyota can be recognized as the two grandfather companies of this manufacturing strategy. Lean manufacturing is super interesting because it is constantly changing and improving. There's a demand for food, then there will be a demand for agricultural equipment. John Deere is one of the largest producers of agricultural equipment in the world and is best known for their production of tractors. Thousands of tractors, utility vehicles, and mowers are made and sold throughout the world. And with a reputation established from over 183 years, John Deere offers the highest reliability of any company out there. Even though the majority of their tractors are manufactured in Waterloo, Iowa, John Deere has expanded its empire outside the United States and has manufacturing sites all over the world. John Deere is constantly looking to improve their manufacturing process, and with the help of Lean, they have done just that. With the assembly of tractors, there comes assembly lines that are human and machine operated. The flow of production comes from parts being sorted into the right order and up to the required specs. Lean aims to cut down on parts that are not up to specs and keeps the level of inventory down by only producing when there is a demand. Lean manufacturing is not only a principle that applies to upper management or higher positions titles of the companies either. Lean is a team effort and requires everyone to be on board, all the way from the CEO calling the big shots to the janitor mopping the manufacturing floor. It applies to everyone. It can even backfire if management tries to implement lean manufacturing without consulting the operators of the manufacturing floor.
The existing techniques of lean manufacturing include Kanban, Conwhip, hybrid, and improved MRP. The Kanban system is a widely used pool-style system that uses signals, often cards, to control the production and flow of material within a process. As part of a pool system, it controls what is produced, in what quantity, and when. Its purpose is to ensure that you only produce what the customer is asking for and nothing more. You can see in the diagram the Kanban system in action and how the deliveries from supplier arrive at a facility such as John Deere. And as the product moves through the line, material is being drawn from the previous processes. This allows the process to minimize work in progress and finished stocks. Next, we have Conwhip. Conwhip control seeks to maintain a constant work in progress at system level by limiting new work from entering a system until a piece of work has exited. The Conwhip, which stands for constant work in progress system, is very similar to a Kanban system, except that this system uses a card that is not associated with a certain part type, but rather only with a certain quantity of at least one. Our next technique is hybrid. A hybrid system is a cross between Kanban and Conwhip. In the event where a local buildup of inventory is excessive, a hybrid system can limit the amount of work in progress buildup in a single cell. The hybrid system can detect problems in a line and block release of parts to the line if they cannot be processed further. You can see the hybrid system in the diagram that shows a part going through the line depicted by the blue line. The hybrid system is depicted by the green line, where the machine, which is depicted as a circle, and the buffer depicted as a triangle. It moves through each, and if there is no problem being detected with that material, it continues to move through the line to the finished goods at the end, which goes back to the original machine. And the red line depicted is the Kanban system. Our last lean manufacturing technique is improved MRP. The primary improvement offered by this is that it computerizes the flow of material and provides an instantaneous review of the quantity of work in progress in any location at any time. This improvement strategy helps to set a schedule as to when goods need to be produced or purchased in order to fill a certain customer order of finished goods by a certain date.
Advantages of lean manufacturing. Lean manufacturing helps reduce excess inventory buildup at each step of the manufacturing process, therefore reducing waste. It also reduces the risk of overestimating demand and manufacturing too many of a product, and then having to sit on that product and not being able to sell them. Finally, if you find a quality issue in one of your parts and have to have a rework of that part, you don't have a bunch of those parts already made that you now have to fix. All of these save time and money. While lean manufacturing has many advantages, it also has some disadvantages. One of these disadvantages is unplanned downtime. In most lean manufacturing techniques, the manufacturing chain is set up as pull style, meaning the last step of the process tells the step before it which and how many parts they need. They tell the step before them, and so on. However, if one of the steps takes longer than the others, and realistically one will, then the steps before it have to stop producing parts and their machines sit idle. Also, most lean manufacturing techniques do not work well in a high demand volatility market. Most companies using lean manufacturing techniques keep an estimated buffer of finished product waiting to sell it to consumers, and as soon as X amount is bought by the consumer, X amount of product begins getting manufactured. This way, the consumer does not have to wait until the product is manufactured to receive it. However, if demand is volatile and changes rapidly, then it can be difficult to accurately estimate how many products to keep in the buffer.
Some of the results of implementing lean manufacturing can be seen in the following two John Deere plants. The Hitachi excavator plant uses DH Lean and Kaizen in their approach to maintain what they call a steel-to-reel process. This allows them to complete a machine in 8 days. Also, we can see in John Deere Berica some words from their senior manager of how they are able to reduce the amount of scrap that their suppliers produce in large quantities. Also, in terms of their purchasing, the most critical benefit that they see is that they are getting their people to see that they have the ability to improve.
Another result of the lean manufacturing is the Deere Production System, or DPS. Robert Lane, Deere's Chief Executive Officer, says, "Our Deere Production System is tailored to low-volume, high-quality production. The pull system replaced a steady pace of production with a made-to-order production system. This means instead of constantly making products, they wait until an order is placed to make the product. This allows Deere to adjust production to seasonal changes in demand for their products." Robert, lean manufacturing has an indirect environmental impact. It tends to eliminate environmental waste alongside eliminating manufacturing waste. However, since lean manufacturing is more about the manufacturing side of waste elimination, most corporations don't quantify how much environmental waste is eliminated.